Hello guys, how are you? Welcome back. Era tswelela ka heat transfer. Go ra re ano ra go lebella the applications of heat transfer. Go ene go ra go kopanya conduction, convection, gote le radiation. Re bona re ka dirisa yang in our everyday life to simplify our lives. Okay, so let's start with a thermal flask. Well, thermal flask here can call it a vacuum flask. So Rari, it is designed to keep liquids hot or cold by reducing heat transfer to or from the liquid. Again, gantsi re tlwaetse gore re irisa gongwe re tshetse metsi a mollo gongwe re ka re tea. Yaanong se se iragalang ha re tshwanetse re kgone go bua gore why e rile ka ene tsela e rileng ka yone. Mo ke rubber stopper, ke rubber stopper ta tshwanela go re itse gore why rubber. Akere hana bere re ke glass silvered walls. These walls di pedi akere kore ga re engwe yana be go re engwe yana. So these are silvered walls. These are silvered walls. Again, ha gare ha, it's a what? It's a vacuum. It's a vacuum. This is a vacuum. Again, mo ke di supportara hela. Let's only sensor we dirilwe say ka plastic again. Kana any other insulator. Yana re sensor re bue yang rubber stopper. Rubber, remember rubber is a what? Okay, to start with, remember this tea, supposing it's at 80 degrees Celsius and the outside room temperature, the room temperature outside of this flask is 20 degrees Celsius. So the natural thing for heat to do is to flow out of the flask. Heat, the natural thing, right? So means se yang go ira like gore yanong ka re constructileng ka teng ra go leka go hokotsa ke te ya go etetse go mo it's a rubber stopper. So this is a pure conductor. Heat from your tea to the outside environment. It's a good insulator. It's a good insulator. It's a bad conductor. Therefore, it's a good insulator. It insulates. Then glass. Why did we use glass? Why not metal? Because glass is a what? It's a bad conductor. Glass is a bad conductor, Leone. Silvered walls. Why silvered walls? They are bad absorbers of heat. Canary good reflectors. Bad absorbers of heat. Right? The liquid that they receive, they are going to reflect most of it back. Berenali a vacuum. Why vacuum? Vacuum prevents heat loss due to conduction and convection, because these ones, they need what? They need matter, right? This conduction needs atoms to vibrate. This one means movement. So there are no atoms here to vibrate. There is no fluids, air, particularly air, right? To do what? To move up and down. So that's how it prevents, that's how it reduces heat loss. So let's see the summary of everything that we have been discussing here. So here is what we have been saying, written neatly. Feature of a flask: reduces transfer of heat by explanation. Feature of a flask: silvered walls. How do they reduce heat? Radiation. They reduce heat due to radiation. They reduce radiant heat. Why? Silver is a bad absorber and emitter of heat. It's a bad absorber, it's a bad emitter of heat. Then vacuum between the walls. Why are we having a vacuum? Conduction and convection do not occur in a vacuum. So the vacuum walls, they reduce or prevent heat loss due to convection and conduction. The reason being that it's a vacuum. In a vacuum, there is no matter to transfer heat by conduction and convection. Rubber stopper: conduction and convection. How so? It is airtight. It prevents convection current, and rubber is a bad conductor, right? Glass walls, they reduce by conduction. How so? Glass is a bad conductor of heat. That's it about the vacuum flask. Let's look at the next item. Well, here we have a solar heating system. We want to focus on this solar panel, right? The solar panel. As we can see, it receives the radiant heat from the sun. And what do we have here? This is a glass. We see the glass here. That's our glass, right? And then here, the black object here, we call it black sheet. It is a what? A metal. It is a metal. Then here, these are network of pipes. These are pipes, right? Okay, just to give you an example, they could be like this. Then maybe they are joined to another pipe here, which goes out, and another one being here, maybe in, out. So there's this network of pipes. Network of pipes. Network of pipes. Network of pipes. We have to explain what are they for. Then we have here a what? Insulator. We have an insulator here, right? So here are the features and their functions. Let's look at them. Glass cover. Here is a glass here. What is it for? Is to trap heat. Okay, glass is trap heat, guys. How lo mo koloing hela ile mo letsatsing o tsetse first wa go shatata compared to how it's the first day. Ke tsa hore ra se tlhaloganya se. So glass traps heat. Correlate a lot of heat tsene mo teng ha e khone go tswa. Network of pipes to increase surface area for heat conduction. Okay, so ha di pipe tse di le ntsi yana di a go khona go increase surface area ya gore di khone go tsa heat from the metal sheet ya black, because I get restile go di mo gape le tsone di pentile ka go black go ra re ja khona go absorb more heat. Okay, ya no ra the network of pipe is copper, because copper is a what? It's a good conductor. Gara it is a plastic, yeah. It's a metal, copper, which is a good conductor of heat. And high rules. I get that's one good thing about it. Black metal base, this one. The metal sheet why re dirisitse yone ntsho gone ka gore black is a good absorber of heat from the sun ya go absorbiwa thata ke yone a black metal base. Why re dirisitse metal? Because metals are good conductors of heat. Again, ha e sena na receiver that heat e tla kgona go isa go di-piping through conduction because it's a good conductor. Again, insulation so it's more like a casing. So kana go ha heat e re trapile a re ke kra ra sena re trapa gape be re e tswe e dute ko tase ke re ka re ya duta ya le go tsentse nenyane le gore e tabe khona go isa kwa ntentsi. Again, so insulator rai ke gore e le ka go reduce heat e ka tswang through conduction. Again, it's an insulator, is a bad conductor. So it's more like re khanela heat ile mo teng re khone go e harness from the sun. Ga re se re batla go thutahatsa environment ra re batla go thutahatsa metsi ke le tsona gore heat ha rena hella go ne hela mo teng di pipe tse di tegereng di heat up then be thutahatsa metsi a mo teng a ba khona go taha mo hot water tank. Again, so to reduce heat loss to the environment through through conduction. Again, okay, cold water leaves the tank at the bottom and enters at the top. Cold water leaves the tank at the bottom. Metsi go ha re ka bona gore go iragalang ke metsi kana tswa ha ya so ha tswa a tsamaya le ko tlase ka gore a bothithwa kae a bothithwa go nna ntse le go godimo kwa ka gore ra itse gore metsi a bothithwa nna kae go godimo. So it's one thing ya wa bona gore go mo beilwe yang go ra ka go ntse yana metsi a go a go godimo by convection because a thutahetseng a batla go godimo a kana re ntse re bua gore if you warm the water it expands, becomes less dense, then it rises upwards. Ke gone bona a hot a le go godimo a cold a le kae a le go tlase akere ke sone se se buiwang gone ha sone se re tshwantse re se tlhaloganye. So that's it about the applications. In our next video ra go lebelela the consequences mathata tankai ka heat transfer mo lehatsheng le re tshelang mo go lona gore yaanong ra re ka mathata a teng ra re go iragala eng akere thank you.